In this question, we're asked to draw the graph of the linear function, so straight away we know that our graph is going to be a straight line. Our function is f of x is 3x minus 1, and our domain or our range of x values is minus 3 to 4. Now all this means here is that they're an element of real numbers. That just means that they can either be a whole, positive or negative number, or a decimal or a fraction. Before we can answer part 2 and 3, we need to actually draw the table for the function. Here's the table. I have all my x values, which I got from having this domain here, minus 3 all the way to 4. So you can see it here. Here's my function, I was already given that. When I sub in the x, minus 3 for x, minus 2 for x, I'll get my y values, and I'll then be able to plot it on a graph. Now, just to remind ourselves of basic algebra and substitution, I'm taking the 3 and I'm subbing in minus 3 for x, and then I'm keeping my minus 1. Minus 3 by plus 3, well 3 by 3 is 9, and a plus by a minus is a minus, so I've got minus 9 minus 1, which will leave me with minus 10. And you continue that the whole way down until you sub in the value for 4. So now you'll see from subbing in for x each time, we've got a y value. And now we can use our x and y answers to make the couples of this function. So for example, the first couple is minus 3 minus 10. The next couple is minus 2 minus 7. And you continue this the whole way down till the very end. And here we have all of our couples, and we got these by taking the x value and matching it with the y value each time. Now we need to plot these points on our graph because we were told to draw the graph. So here I have a graph, and in your Leaving Cert you'll always be given the graph and you just have to plot the points. So here my graph goes up and down as far as 11 and across and back as far as plus and minus 9. Now I don't need to plot all of these points, so I'm going to only plot the ones that fit on my graph. So for example, I'll go minus 3 on the x-axis all the way down to minus 10, so my first point is here. I then continue with my next point, minus 2 minus 7. Again, go to the x-axis, go down to minus 7, and my point is there. Next I have minus 1 minus 4, and here we're going to begin to see a pattern emerge. I can already see a linear or a straight line happening. 0 minus 1 will leave me here, 1 2 here, 2 3 here, 3 8, and 4 15 is too far away, so we can leave off 4 15. Now taking a ruler, you're going to draw a line and connect those dots. And now you can see the linear function is drawn. Now we can start to use our graph to estimate f of 1.3. Well, that's another way of saying f of x. So you go along the x-axis and you say, well, whereabouts is 1.3? Could be roughly there. And then you follow that line up to where it hits the linear function, and then you come across. And you could argue that it's roughly 2.5. The trick here is that it says estimate. So once you can show that based on your graph it's roughly 2.5, you'll get the marks. Just as we used f of x and we followed up from the x-axis and across to the y, we're now just doing the opposite here. It's telling us that we need to find the value of x, so our value is going to lie along our x-axis, and we use that y equals minus 6 as a guide. So in the exact same way, you go from minus 6 across, it touches it here, and you come up. And again, it's an estimate, so you're looking at roughly minus 1.5. we can verify this because the function is 3x minus 1, and it's telling us that let that equal to minus 6. And if we solve for x, we're left with 3x equal to minus 6 plus 1, which we know 3x is equal to minus 5. And when you divide minus 5 and 3, you get x equals minus 1.66, and so on. This next question proved a little bit difficult for some of you. So we're told that a car passes a point P, after which its speed v in minutes per second is given by the function v equals 15 minus 3t. So if we think of v as f of x and t as x, then we have a linear function, and t is just the time in seconds. So they're asking us to draw a graph of v, or if we like to think of it as of f of x, for 0 is to 5, okay? And then we have to use our graph to estimate these three things. So first of all, let's make our table. So what we do know that our function is linear, and we have a domain so we can make a table. Our table will be a little different than questions we've looked at before, because in this case t is now our x, and we know that because t is here in the domain, and v is now our y. So what we're saying is, in relation to time, what speed does the car do? That's why t is here and speed is here. This is just our function, and it's linear. So let's substitute in all our values for t from our domain of 0 to 5. So my values are 0, 1, 2, 3, 4, and 5. So pause this video now and see can you fill in those figures. So with basic substitution, we have 15 minus 3 multiplied by 0. Well, 15 minus 3 times 0, which is 0, will just leave you with 15. So one of your points is 0, 15. And let's populate the rest of the values now. So now that we have our table, we're going to use our t values and our v values to make a graph. So we need to put these into couples. My first couple is 0, 15. My next couple is 1, 12. Next is 2, 9. 3, 6. 4, 3. And lastly 5, 0. And we're going to plot some of these points on a graph. So let's begin to plot some of these points. It's not necessary that we plot all of them, but once you have over half of them on the graph, you'll be able to see the clear line that's going to appear. So because my graph only goes up and down to 11, we can forget about 0, 15 for the minute. So let's start with 2, 9. So to plot 2, 9, I go to the x-axis at 2 and I go up as far as 9. So my first point is going to be there. Now I look at my next point, which is 3, 6. I go to 3, up to 6, and my next point is here. Then I look at 4, 3. Again, I go to my x-axis. I go up to 3, so my next point is here. And then finally 5, 0, it stays on the x-axis there. Now taking a ruler, join them points up. And as we expected, because it's a linear function, we have drawn a straight line. If I was to plot this point and this point here, they would just be further up here. But as you can see, it's unnecessary because I have 4 out of the 6 plotted. So now we need to answer the 4 questions based on our graph here. So the speed of the car at t, they want to find out what speed was the car doing at 2.3. So t is a replacement for our x-axis, and we already know that from our table. So you need to do an estimate of where 2.3 might be, and it could be about here. So you need to draw a line up from your graph using a ruler to where it hits off the blue line, or the linear function, and then come across, and you'll find out what speed the car was travelling at. So let's do that now with a ruler. So using a ruler, go up as far as from 2.3 up to where it touches the graph, and then when you turn your ruler, go from where it touches the graph across, and you'll see that it's roughly 8. Now we're looking at the time at which the speed is 10 miles per second. So we're no longer going up from the x-axis and across. We're now saying, well, at 10, what's the speed? So we come in and down, and it's roughly 1.5. So at 1.5, the speed is 10. For the next two, for part 3 and part 4, because our graph didn't go all the way up to the 0.015, we can't see that the answer here is 15 meters per second. But basically what they're asking is, at what point does it cut the y-axis and cut the x-axis? So cutting the y-axis, it cuts it at 15, so it's 15 meters per second for this one. And your graphs will be far more accurate than mine. And then obviously if you're looking for the time, it's when it crosses the x-axis, which is here at 5 seconds.